Hey guys, welcome to my problem solving videos. So in this we will be solving one of the famous DFA question. So let me explain what we have to exactly do in this question is, suppose we have been given an alphabet that is accepted, that is going to be your A comma B exactly, but you have to keep in mind that the string should not end with string not ending with AAB or ABA. So now if we have been given AAB and ABA, that means that, let me just show you an example. Like suppose we have a state Q0 initial state, and we go to A, then form a Q1 state, then again we go from A and form another state Q2. Now this is accepted, but if a B falls, then it is not accepted. Q3, these two will be accepted, and the initial state will be accepted as well, but Q3 will not be accepted because we do not want a string ending with AAB. But we have to also check for the similar that we have this condition ABA as well. So for that, let us assume in this particular same situation what can be the possibility. So we go from A to Q1. Now if we have a B, we can just simply jump from here like B and form let's say Q4, a final state in itself. AB is accepted, but if we have another A, it is not accepted. Now you might be assuming that there could be a better position to connect just this, but it is not possible because A is a final state. Now this is a possibility of assuming that the possible states can be formed from these two. Now we have something called let us say we have a string um, AB, AAB, then ABB, ABA, B, and double A. Yeah. Now this string is accepted because it doesn't have AAB at last or ABA. But if we will check this particular string in this, it is going to fail. Let us say A, B, then A, and it is working for only these three strings. What about the remaining? So now let us make the final deterministic finite automata for this particular string to work. So what we can say is that we go from Q0, A, and to Q1. Now there could be a possibility that we have a string like BAB or maybe BAAB A. So we can have a B input at the first. So we place a B over here. Now when we have this, we can just simply make a cut. Now let's go for B. So this is also accepted, Q4. Let me just say that this diagram is the final transition state diagram. So this is going to be your Q2, open state. Single means non-final states. That's it. And Q5. And just display these same A, B, A. That's it. Now A, B. Then if A comes, it goes over here. Now we have one more A. What we can do is we can just simply send an A from this state. A, B, A, and when the A went, it came over here, cancel. Now B, the B went this side, cancel. Now we have one more B. So from B, now if we say we have to link B to somewhat over here, it's not possible. We cannot create a self loop over here because it will A, B. This is wrong. So what you can do is just simply bring this B back to the initial position. That's it. So this is your B. Now B is cancelled. Again A falls over here. B falls over here. And we have another B. Now what we can do is we can link Q4 to Q0 and just say B. Cancel. Then again A falls over here, B here, A. So done. Now what if we have this right over here? So B, A, B. Now we have an A. We cannot simply go back like this because we have B for it. Now what we can do is we can make an exception for it because this is ABA. So this is not accepting. We can just place again A. So just from Q3, like we went from B, cancel, then A, cancel, A again, cancel, then B, cancel. Now we have an A condition, join Q3 to Q5, A, cancel, then Q5 to Q2, A, final state. So let us check. We have a B transition, A transition. Now let us check for one more condition. What if we had multiple A in between, like B, A, then many B's, and then A? This is accepted. Now we have the first B, then A, then A. Then what happens? We cannot go this side or anywhere else. So we have an A condition. So what we can do is we can apply a self loop over here for A. So B, A was done. Now for rest of the A's, it will be done in the Q2. Then for triple B, what we can do is we can move from here, B, single B, cancel. Now for double B, it falls over here, one B is cancelled, then self loop, B is cancelled, then A, cancel. So this is the final deterministic finite automata for the given question. So I think this is the final. Let me just cross verify. Let's take one more string. Let's assume we have combination of this A, B, a non-accepting. All right. So A, B, A. So we have not set up for a B condition. So what you can do is we went from A, cancel, then again A, cancel, then B, cancel, then A, cancel. Now we are left with B. For B, what we can do is we can just simply put over here a B condition, then A again. So Q5 is non-accepting. They are not accepting. So that's it. Let me just see. B. So yes, this is the final deterministic finite automata for the given question. This is the perfect and final. That's it. So thank you for watching my video. I hope this made your view on this particular question really clear to this point. So thank you.